So here we're continuing with Algebra 2 with Trig, Semester 1, Final Exam Review. This is continuing with the Unit 2 portion. Here are the zeros of our function. This looks like it's x to the fourth. So as we set these equal to 0, we see that we're going to have x equals -2 and x equals 1 as our x-intercepts. -2 and 1. This is a degree of 4 because it's squared and squared. So if we multiplied that all out, we have x to the fourth power. The main thing that's important about that is it's even. That tells us it's going to be going in the same direction. The leading coefficient of 2 is positive. So that means it's going to be going positive in this way, and because it's even, it's going to be going in the same direction. So this is going to come down, it's going to bounce because it's squared. When the x-intercept is squared, it's going to bounce on that spot. Now we don't know really how high it comes up, but it comes up and it comes back down, it will bounce again. So this is just an approximation. If we needed more exact, we could use our calculator, but we don't need that. We're just using the end behavior and the zeros to help us determine what the graph should look like. As x approaches -infinity, the function is going to go up. As x goes to the left, it becomes negative. The function is going to infinity. As x approaches positive infinity, as x moves to the right, the function is also approaching positive infinity. It is also going up. The range and the domain. The domain is going forever in both directions. You can plug in any x value you want. Your range is greater than or equal to 0. 0 is your lowest point for this equation. For expanding. Now we could write this out 3 times with 3 parentheses and just FOIL it all together. That would totally work. But we also learned something called the using Pascal's triangle. We could use the binomial theorem, which we start out with 1, 3, 3, 1. It's a pattern that comes from Pascal's triangle. We take our a term, which is 2x. We write that next to each one of them. We write our b value next to each one of them. Put our pluses in between. Now this is to the third power, so we're going to say 3, 2, 1, 0. Those are all for the 2x squared, or the 2x. And then for the -3, we're going to say 0, 1, 2, and 3. Notice that the sum of the exponents, 3 and 0, adds up to 3. 2 and 1 adds up to 3. 1 and 2 adds up to 3. 0 and 3 adds up to 3. So when we simplify this, that's 1. -3 to the 0 power is just 1. So we have 2 cubed and 8, which is 8, and x cubed. Here we got a couple different things going on. We have the 3. 2 squared is 4. -3 to the first power. We get 3 and 2x to the first power, and this becomes positive 9. This is 1 times 1 times -27. So our final answer is 8x cubed. This is a negative 9 times 4, which is 36, x squared, 6 times 9 is 54. And negative 27. So, this method is definitely easier than multiplying if your exponent is larger. With a cube, maybe you could do it either way, but this is the way we learned it in class. Go ahead, pause the video, and go ahead and try number 25. So what we're going to do is start out with 1, 3, 3, and 1. Take our x cubed, our x squared, our x to the first power, our x to the 0 power, 3y to the 0 power, 3y to the first power, 3y to the second power, and 3y to the third power, with pluses in between. So here we get x cubed. We're going to get 9x squared. This square only is affecting the 9, not the 3. 9 times 3 is 27. X and x times y squared. And then this is 27y cubed. We're going to add our two functions together. That's going to give us, not 20, it's going to give us, we're adding. That's what was confusing. We are adding, that's going to be a plus. So this is 7x plus 3, just our like terms. We're going to subtract. Now here, the parentheses are super important. If it was a binomial you were subtracting. But this is not. So this is just 5x minus 2x, which is 3x, and then the 3. Now we're going to multiply. Well, we often like to write a monomial before a binomial. Doesn't really matter. And you distribute through. Here we're going to divide. So here we'll leave it in this fashion. We could go through and try to actually divide that into this problem. Nothing fancy happens. So we're going to leave it into this format. That's finding f of g of x. Now we have to talk about the domain. Now, when you talk about the domain, this domain is all real numbers, and this domain is all real numbers because they're both linear. You can plug any value of x. So when you add two numbers together, the domain is still going to be all real numbers. It's where the two domains are the same. And if you're talking about all the numbers, and all the numbers, they're the same at all the values. So in subtraction, we get the same thing. And multiplication, we get the same thing. It's all real numbers. One way you can kind of think about it is that we have a linear equation, so that'll be all real numbers. A linear equation, all real numbers. A quadratic, still all real numbers. Now, in this case, it'll be all real numbers except for what makes the denominator 0. So in this case, the domain is all real numbers except x equals -3, because you can't have a 0 in the denominator. Which of the following represents as f of g of x? So the f function is something squared plus 4. So we're going to put our 3x squared inside of that, our g function inside of the f. We're going to square that, so that's going to be 9x to the 4th plus 4. Just C. Just a couple more left. So here we're going to look for the inverse. So do the inverse, we switch the x and the y. We add the 2. We divide by the 3. So we're dividing both terms by the 3. We're dividing the x by the 3, so 1/3 of the x, and 2 is being divided by the 3. Now this is f inverse, so that's why they're using the inverse notation. We're going to graph here. So this is a quadratic that's been translated up 4 units. Now we know that the parent function, when x is 1, y goes up 1. When x is 2, y goes up 4. When x is 3, y goes up 9. So we get our quadratic parabola that goes that way. We would also have it going this way. But we're only going to use x values that are greater than or equal to 0, so we're only using this side. Now we're also going to graph the inverse. So we work with our equation y equals x. We need to reflect this. So if this original graph was 0, 4 and 1, 5 and 2, 8, when we do our inverse, it's going to become 4, 0, 5, 1, and 8, 2. That's our inverse. So this is f of -1, and this is f of x. We can put an x with that if we with f inverse of x and f of x. We graphed the inverse by looking at the table and switching the x and y. So we're looking for the asymptotes. So what I'm familiar with this graph is that it's going to be translated up 4 units. We're going to have a vertical asymptote at 3. It's going to be translated up 4 units. I would expect it to curve here and here, but the asymptotes that we're looking for is x is 3 and y is 4. The equation that we're looking for, we see that when the x's have the same degree or the same exponent, the horizontal asymptote is the leading coefficient. So we're not at -2, so that's not the equation. Degrees are the same, so the leading is not at 1/3. The degrees are the same, so you use the leading coefficients, -3 over -1, which is 3. That's exactly where it's at. Horizontal asymptote uses the leading coefficients. Now, let's just compare that with the vertical asymptote. The vertical asymptote is when the denominator is 0. So this would be -3, which is not This would be negative 1/3, which is not. This would be at -1, which it is. So that had the correct horizontal asymptote and the correct vertical asymptote. To find x-intercepts, that's where we set the numerator to 0. That's where the function is 0. So the y value is 0 when the top of the equation is 0. So it's one of these two answers. Then to find the vertical asymptotes, we set the denominator equal to 0. So x and x, it looks like 6 and 2. It's got to be a positive 6 to get to 4, minus 2. So 6 minus 2 gives us 4. So x equals -6, x equals positive 2. -6 and positive 2. Last two, horizontal asymptotes. So if the degrees are the same, we use the leading coefficients. So we've got 2 divided by 1/2. Now I don't like to divide by a decimal because I know how to divide by a fraction, because you multiply by the reciprocal, and that gives us y equals 4. That is our horizontal asymptote. Then here the degrees are different. This bottom is larger. The degree is 2, the degree is 1, the bottom is larger, so the bottom is getting bigger, faster. So that means this fraction is only going to get smaller, 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 all the way to just about 0. Good job.